Hi students, in this video we're going to look at the index laws and how to use them to simplify expressions. Right, so after watching this video you should be able to recall the index laws and also apply them to simplify simple expressions. Alright, so the biggest thing we have to remember is our index notation. So when we're looking at a term like this here, we've got 5 to the power of 4. That 5 we call the base. That power 4 we can call it the power or the index or the exponent. Okay, all words that mean the same thing, and that you can use whichever one makes the most sense to you. In a textbook or as you go through maths, you might use more of those words as you go, but knowing they all mean the same thing is quite important. Now, from here as well, we can also say what this actually means. So 5 to the power of 4 means 5 multiplied by itself 4 times. So 5 to the 4 is 5 multiplied by itself. It's repeated multiplication. 5 multiplied by itself 4 times. Alright, so our index laws, they're just used to help us simplify expressions that contain powers, or as we've already said, indices is another name for powers, hence the index laws. So they are meant to make things simple. So it's meant to take something quite complex looking and break it down and to make it into something simpler that is easier to work with. In order for index laws to be used, there's a couple of key things that need to be understood. Expressions must have either the same base or the same index. Okay, so same base or same index. The other thing to know, index laws cannot be applied to terms that are added or subtracted. So our index laws are solely to do with the situation where we are multiplying or dividing. We are not doing any additional subtraction between terms with our index laws. Right, so let's just go through them. So we've got 6 index laws we're going to look at today, and they're all ones that you need to know off by heart. So our first one, we've got a to the m times a to the n means we have a to the m plus n. So really we are adding those powers. Now the reason for that we'll show in this example. So if we've got 4 to the 3, that's 4 times 4 times 4. That's 4 to the 3. And we multiply that by 4 times 4 times 4 times 4. That's 4 to the 4. Then altogether we have 1, 2, 3, 4, 6. We have 7 4s. That's 4 to the power of 7, which is 3 plus 4. We have 3 4s multiplied together, another 4 4s multiplied together. So in total we have 7 4s multiplied together. And then when we divide our terms with the same base, we subtract our powers, so it's the opposite. When we multiply our terms with the same base, we add the powers, so multiplication and addition go together. When we divide our terms with the same base, we subtract the powers. So we're subtracting our powers there. Now, again, how that looks, if we've got 5 times 5 times 5 times 5 times 5 times 5, then we divide that by 5 times 5. So we've got 5 to the 6 on top and 5 squared on the bottom. What's going to happen is we can simplify this fraction by saying 5 divided by 5 is 1. 5 divided by 5 is 1. So the 2 5s on the bottom cancel out 2 of the 5s in the numerator. So now we have 5 to the 6, take 2. We've cancelled out 2 of those 5s. We only have 5 to the power 4 left. And those are our main 2 basic index laws. All right, our next one, a to the n times a to the power of m means we multiply our powers together. Now how this one works out, let's say we've got 7 squared cubed, that's 7 squared times 7 squared times 7 squared. Now using our first index law, we have to add these powers together. So we've got 7 to the power of 2 plus 2 plus 2. We're multiplying, so we add our powers. That's the same as 7 to the power of 2 times 3. Right, so we're now multiplying our two powers to give us 7 to the 6. We have 6 sevens multiplied together there. Now the fourth law, a to the power of 0, or anything to the power of 0, except for 0, so a can't equal 0. Anything to the power of 0 always equals 1. Let's have a look at why that's the case. Let's say we've got x to the power of 5 times x to the power of 0. Now using our first index law, we need to add our powers together. So that's x to the power of 5. Now let's rearrange this equation. Let's divide by x to the 5, divide by x to the 5, x to the 5 divided by x to the 5, those just cancel out to 1 and 1. X to the 5 divided by x to the 5 cancels out to 1 and 1. So what we are left with is x to the 0 equals 1. And that makes sense. If we have x to the 5 times x to the 0 equaling x to the 5, if we get the same number, then this number just has to be 1. X to the 5 times 1 also gives us x to the 5. So there's a little reason for why that's the case. And looking at this one here, we've got 4x to the 0. Well, that whole thing is to the power of 0, so that's just going to be 1. Now that's different to our second example here. We've got 4 times x to the 0. So note that this power 0 only applies to the x here, not to the 4. The 4 is still on its own there. So we can write that as 4 times x to the 0 is just 1, and that equals 4. So be on the lookout. Make sure you recall and understand what terms have the 0 power on them. All right, 2 more index laws to get through. Law 5, if you've got 2 terms in brackets and a power on the outside, that power needs to be applied to both terms. So in this situation here, in our example, we've got 2 to the x cubed. So that'll become 2 cubed times x cubed. 2 cubed, that's 2 times 2 is 4, times another 2 is 8. So that will become 8x cubed. So that power on the outside needs to go onto both terms on the inside. Remember, this only works for multiplication. It does not work if on the inside the brackets have add or subtract. And then finally, basically the same rule, just with a fraction. If you've got a fraction to the power of m, take the top to the power of m and the numerator and the denominator, sorry, to the power of m as well. So here that will become z squared over 8 squared, which will just be z squared over 64. Nice easy one there. Now this one here, let's say we want to simplify this expression. We could try and expand out 10 to the 4 and 5 to the 4, but we're not going to do that. What we're going to do is use this index law, but almost in reverse. So that power 4, I'm now going to write on the outside. So it's still 10 to the power 4, it's still 5 to the power 4. I've just put that power on the outside of the brackets. Now on the inside of the brackets, I can simplify that. 10 divided by 5 is 2, and the power of 4 is still there. And now this is a much easier value to calculate than the one before. So we've got 2 to the power of 4, that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. Much easier to calculate that by taking that power to the outside first and then simplifying the brackets. Alright, so after watching this video, you should be able to recall the index laws and then apply the index laws to simplify some pretty simple expressions.